Hello, this is Katotreva Thomas, and I'm presenting about my student result prediction with artificial intelligence. Yeah. Start by talking about the problem that should be solved in our community. There is a problem of students in the universities finding it hard to go through the different stages of education alone, because in universities, lecturers are not there to always give you time, guide you. They're there, but like that kind of resource is quite limited. It's quite fair. It's not so effective. So this is a problem because now students are able to go through difficulties after graduation since they are not given the right path to follow. And how I can use artificial intelligence to solve such a problem. Uh, there's a project that I would want to make whereby it predicts the students' results according to their past results. In other words, it predicts the results that the student would get in the future according to the results that they have so far put into the project. Such a project can let a student know which path they are taking, whether they're on the right path or not on the right path, so that they can adjust and get to be better. Yes. And the type of data that I will use for my project, I will use numeric data for the results in terms of numbers, percentages, and I also use daytime data for me to relate the period in which these obtained results were achieved or recorded. The differences between supervised and unsupervised learning. Supervised learning is where an algorithm is trained with labeled datasets, where unsupervised learning is where an algorithm is trained with data which is not labeled without any kind of human intervention. That's what I would say is the difference in general. I would also say another difference between unsupervised learning and supervised learning is that in supervised learning, prediction is possible. You can make predictions with the data that you are given, but in unsupervised learning, it mainly deals with grouping data according to any hidden patterns or properties discovered. Techniques in supervised learning, there is classification, whereby you deal with class of objects or discrete values. Yes or no, true or false, male or female. I can use such a technique in my project in order to tell whether a student is having good marks or bad marks. Then there's also regression. Regression deals with continuous values, for example, salary amounts, age. So with such a technique, I can use it in getting in dealing with the results of a student from their tests, from their exams, from their coursework. Talk about unsupervised learning techniques. There are two. Here, we have clustering and association. Clustering can be used to group different sets of variables according to discovered properties. Yeah, whereby different data is categorized according to any similarities that are discovered by the algorithm. I can use such a technique in order to group students according to their stages of education, whether one is a first year or second year. Then in terms of association, I can use such a technique to get the relationship between different sets of data, because such a technique mainly deals with creating relationships from the different sets of data that are presented. I'll talk about the challenges that I'm likely to face with this project. Challenge number one, getting the proper data set that I would use for the successful operation of the project. That would be quite a big challenge. It would have the most impact. Then another challenge would be ensuring that the information of the students in terms of their results, any kind of personal information, there's a chance of it facing a challenge of insecurity. That is challenge number two. Challenge number three is having a necessary skill set for me to make the project work as efficiently and effective as possible. Possible solutions to such challenge that I'm facing, I would look at first planning and studying whatever data that I am to use for the project. in a way that whatever data I use must be from trusted sources, it must be clean, it must be accessible, must be well governed, it should be secure, it should be very reliable. And also a challenge of me dealing with the insecurity can be continuous monitoring of the project itself in order to find any unidentified or suspicious activity. That would be a method to overcome such a challenge. I would have to really put the data in a reliable data management environment in order for it to be secure. In terms of the skill sets, I would propose continuous training, practice, and consultation. Consultation from friends, from lecturers, from anyone who's skilled, because you share knowledge by receiving it and also sending it. Differences between accuracy, precision, recall, and F1 score. Accuracy refers to how many data points were detected correctly by the machine learning model. In other words, in terms of classification of data, the accuracy can be determined by dividing the sum of the true positives and the true negatives by the total number of items that are classified. In other words, accuracy is a formula here. The true positives plus the true negatives is the sum that is divided by the true positives, is divided by the sum of the true positives, the true negatives, the false positives, and the false negatives. I'll talk about the false negatives. False negatives, true positives, true negatives, true positives, talk about those things later. Then there's precision. Precision describes how many detected items are truly relevant. In other words, how much you should trust your model when it makes a finding. Like how precise is your model? Accuracy just talks about how many data points were detected, like what you wanted to find from the total role that you had used. Then precision is about how much to trust this model. Precision can be calculated by dividing the true positives by the overall positives, that is precision, is equals to the true positives divided by the sum of the true positives and the false positives. Then recall is the measure of how many relevant elements were detected by the program. In other words, it is the measure of how much the program can find of the thing you are looking for. Recall is calculated by dividing the number of true positives with the number of relevant elements. Recall, the formula is the true positives divided by the sum of the true positives and the false negatives. Recall is, as it says here, it's the measure of how well this program can tell something is what you wanted to look for from what it was given, from the data that it was given. How well it can tell, how well it can recall that this is what you wanted, from the data that is given. F1 score is a combination of recall and precision. The thing is, in some situation, you cannot only depend on accuracy. So it's better to depend on accuracy, precision, and recall. Because in some situations, the data that is presented to the algorithm is not balanced. So in such a way, you cannot depend on accuracy because it can lead to negative impacts. So F1 score is a combination of recall and precision. It is calculated by multiplying the quotient of the products of precision and recall and the sum of precision and recall by 2. In so many words, but the formula, as it says there, F1 score is equals to multiplying the, okay, you get the quotient of the precision and you get the quotient of the product of precision and recall and the sum of precision and recall, and the result obtained is multiplied by 2. That's what F1 score is. In other words, you can have precision, you can have recall, but it would be better to get the combination of the two, which is why there is a F1 score. The results obtained from the equation for the F1 score range from 0.0 to 1.0. The higher the F1 score, the better. For more clarification, precision quantifies the number of positive class predictions that actually belong to the positive class. Well, recall quantifies the number of positive class predictions that are made out of all the positive examples of the dataset, which is what I was saying before. From all the positives, positives means where Positive is where the predicted value is 1, and negative is where the predicted value is 0. And an algorithm is true or false where there's a difference. An algorithm is false where there's a difference between the predicted value and the actual value. And it is true where the actual value and the predicted value are the same. This is all from the confusion matrix, which is right here. We have our confusion matrix is just a table that is used to determine the performance of the models from a given data set. And this is mainly in terms of classification, as I said earlier, true or false, yes or no. So here we have a table that combines it. There's the side of the predicted values, the side of the actual values, and there's where they are positive, that's 1, negative is 0, positive is 1, negative is 0. As you can see here, we have true positives and true negatives. That's when the predicted values and the actual values are the same value. They're both 1, 1, and 0, 0. And where they are different, we have false negatives and false positives. The evaluation metrics for the project. My project bases on, I would say, regression characteristics, whereby the information that I use is continuous, keeps on changing. So the most appropriate ones, or one of the appropriate metrics I would use, is the use of the mean absolute error, which refers to the sum of the absolute values of all the errors identified from the program. In this way, you can tell how correct your algorithm is. Then I would also use the coefficient of determination. This metric shows how the real values vary from the curve created in the model. The higher the value of the coefficient of determination, the more correct the value is determined by the model. With such a metric, with such a method, I can tell, I can compare the real values and the predicted values so that I can evaluate how correct my outcome is. These are the references that I used for my work. The evaluation metrics, most of them are videos from YouTube. And also, these are the references that I use. Thank you very much. Yes. I touch over Thomas. Peace. So what do I do now? Stop sharing. Great. Do you think I was recording?